Okay, today we're going to talk about adjacent and vertical angles. And to do so, let's just review really quickly just the classifications of angles. So these are all just classifications. In other words, if I asked you to classify angles, this is what I would mean. Either acute, right, obtuse, or straight. Okay, and again, for most of us, this is going to be a review. So if this is a review to you, you don't necessarily have to write this down, but it's not bad to just remember. Acute means less than 90. A right angle means exactly 90. Obtuse is between 90 and 180. Understanding, the fact that it actually has to be greater than 90 but less than 180. And then finally, a straight angle is exactly 180. Okay? Those are going to be the classifications of angles. Next, we are going to talk about how to name an angle. Alright, so for naming angles, let's say we have this angle right here. Call this point A, point B, and point C. To name an angle, what we do is we start at any particular point, as long as it's not the vertex, or in other words, where it meets, and we just follow that path. So if I start at A and I go, if I start at A and go to B and then to C, notice that would be, I would call it angle using that symbol, A, B, C. Understanding the fact that this center angle, or the center point right here, has to be the vertex, which is the point where the two lines meet. So that's how we name angles. So why don't you try to name this angle here? Let's say we have an angle, an obtuse angle. We'll call this X, Y, and Z. And do me a favor, label it name it two ways. So try to name it two ways, and I'll give you about 10 seconds to do that, and then once you're done, I will show you how the correct way to do that is. Okay, so hopefully you got that. The first one could be angle X, Y, Z. And then the only other way would be Z, Y, X. And if you did either of these, that is correct. So for example, if I said, all right, name this angle, and you chose this one, that's correct. Or if you chose the second one, that's also correct. So it doesn't matter how you name angles in the terms of choosing one or the two. The only thing that does matter is, if you notice, the Y is in the center, because again, that's the vertex. That's where the 2 points, or 2 lines, I should say, come together. Alright, so a couple of vocabulary terms. Let's first of all talk about adjacent angles. Alright, if we talk about the word adjacent simply means next to. So the person you're sitting next to, you are actually adjacent to them. So if I were to draw an angle, and then maybe draw a line coming out of that, let's label our lines, or name our lines, so we don't get confused on this. let's just put some points in here, and these are just arbitrary. A, B, C, and D. So adjacent angles simply are ones that are going to be next to each other. All right. So if we have angle ABC, which is right here, I'll write that as angle ABC, and I would say that that is adjacent to ABC is adjacent to, and then I would choose the next angle, the angle that's next to it. So CBD. So ABC is adjacent to CBD. In other words, it's right next to. They share a common vertex. Okay, that's kind of the important part. They share a common vertex. So let's try this. Let's draw a couple angles here. Let's just call this, for the ease of labeling, let's call that angle 1, angle 2, and angle 3. That's another way you're going to see these. So for example, if I were to tell you which angles are adjacent, angle 1 and angle 2 are adjacent, angle 2 and angle 3 are adjacent. They're next to each other. They share a common point. Angle 1 and angle 3 are not. Now, the reason being, they do share a common vertex, but they don't share a common side. So if you notice, there's a space in between, and that's obviously angle 2. So by definition, if we're going to write adjacent, it means where angles share a common side and have the same vertex. Okay, so they have to have a common side and vertex. That's kind of the key with talking about adjacent angles. Hopefully you have that down. Next, we're going to talk about vertical angles. Vertical angles are opposite angles that are formed by the intersection of two lines. So if we go like this, let's say those two are lines. Let's call this angle 1, 2, 3, and 4. The vertical angles then in this one would be 1 and 3. And then also 2 and 4. Okay, so if we write that out, I would write angles 1 and angle 3 are vertical. And then I could also write angle 2 and angle 4 are vertical as well. Okay. The nice thing is vertical angles are also congruent. Okay, so vertical angles are congruent, and congruent means they have the exact same measure. They have the same value. All right, so make sure you write that down. Vertical angles, not only are they opposite of each other when you have two lines, but they're also congruent. Alright, so let's flip in our books to page 274. Alright, and on 274, let's take a look at number 5 first. It says, name 2 pairs of adjacent angles and 2 pairs of vertical angles in the figure. So, adjacent and vertical. So let's call this 1 and 2, and 1 and 2. So they want 2 pairs of adjacent angles. Excuse me, 2 pairs. So that just means 2 angles. So we just need 1 adjacent and 1 verticals. Sorry about that. So the adjacent angles in number 5, there are multiple answers on this, but let's choose angle FGH. Alright, so if we're starting with that one, there's 2 angles that could be adjacent to that. I'm going to choose angle HGJ. So those would be adjacent. And then if I'm still looking at number 5, I have to choose angles that are vertical, in other words, opposite. So let's say I choose angle HGJ. HGJ. The vertical one to that is going to be angle FGK. Those are going to be adjacent angles and then also vertical angles. So why don't you try number 6 real quick? There are a multitude of answers there. I'm just going to go over some possible solutions. So once this is paused, give yourself a chance to try it, and then you can resume it, and then we'll see how you did. Alright, so these are just some sample answers. The ones that are next to each other, really, I mean, if you just start with any angle and just look the one next to it, you're going to be right. But let's talk about the vertical ones, because there are some that look vertical but are not, but they actually... anyway, so let's look at it. If you look at angle NMP, the one that's vertical to that would be SMR. Angle NML is going to be vertical to RMQ. And then just one more, for example, PMQ. Angle PMQ is vertical to LMS. Alright, so now let's take a look at number 8. The directions say tell whether the angles are adjacent or vertical, then find the value of x. So number 8, at the x degrees and 35 degrees, those are adjacent. They're next to each other, not opposite. So number 8, they are adjacent. And then if we think about it, x plus the 35, those form a right angle, so that's going to equal 90. And if we look at this carefully, we see that we actually have an algebraic equation. So what we want to do is just solve for the variable x. In other words, we want to get x by itself. So what's in the way of positive 35? We're going to subtract 35. So these cancel out, and we're just left with x on the left side, and on the right side, 90 minus 35 gives us 55, so x is 55 degrees. Alright. So let's try number 11, and then I'm going to have you try some on your own. 11. If you notice, they're not next to each other, they're opposite. So that means that they're actually equal. So if we look at the first angle, which is 75 degrees, that's going to be equal to 4x minus 25. So we have to find the value of x. So, excuse me, I skipped a part. Vertical angles. Alright, so our first answer is that they're vertical angles. Secondly, we have to find the value of x. So again, we want to try to get this part by itself. There's a negative 25 in the way. So to get rid of that, we're going to add 25. We're going to add 25 to this side as well. These cancel out, which means I'm left with 4x. 75 and 25 gives me 100. 4 times x is 100, so I'm going to divide both sides by 4. these 4's cancel. I'm left with x, and 100 divided by 4 is 25. So x equals 25. Alright, why don't you try numbers 12 and 13 on your own, and then I will go over these in just a minute. Let's see how you did. Number 12. We have, first of all, they are adjacent angles. They are next to each other. And so we have 4x plus 2x equals 90. Okay, and I really should put the degrees up here. What we have to do first, we have to combine our like terms, so 4x plus 2x. If you think about it, when you were adding in kindergarten, it was just like 4 oranges and 2 oranges. Gives us 6 oranges. Alright, so now what we're going to do is we want to get x by itself, so we're going to divide both sides by 6. And x equals 15. So we have 2 answers here, adjacent and 15. And let's try number 13. First, we'll go over 13. You should have already tried it. They are next to each other, so they are adjacent. Okay, so in this one, it's saying 7x plus x plus 20 is going to equal, if you notice, those are going to form a straight line. So if you add those together, those are going to equal 180, which is a straight angle. So I'm going to combine my like terms first. 7x plus x is 8x. So plus 20 equals 180. And then, again, I'm trying to get this by itself. So positive 20 is in the way. So if you subtract 20 from both sides, 8x equals 160. And I'm going to write that on the next page just so I have enough room. 8x equals 160. So if I divide by 8 on both sides, x equals 20. So 160 divided by 8 is 20. So 2 answers again. We have x equals 20, and then also adjacent. So make sure we realize that there are 2 answers there. Alright, so you get started on your practice. Make sure you take your time and give it your best.